Alright, stats, welcome to a quick video here for your notes on Monday. While I am gone, we are in this packet. If you don't have this packet, there's a few extra on that front desk that is covered in paper. Just go find that if you need that. Anyway, watch this video, get this down, practice with your calculator if you don't have a calculator. Get that out. Pause this video at different times to, again, make sure you know how to type things in, find answers. Today, we've got some in-house sponsors here that are falling down a little bit. First off, we've got Laura Barr, Cliff Barr. Look at that. They're planting 1 million trees, which is great. We can make some more copies. All right. And then a lovely St. Louis-based coffee house there. We thank our in-house sponsors. Their support. Anyway, have this sad. We should probably finish this on Tuesday. Then I'm gonna maybe give you a few more notes. Might have an in-class assignment at the end of the week, and then start looking at our baseball projects. All right, so here we go. We are gonna go to. We've done page 1 and 2 together in class. If you didn't know those notes, get those from somebody. Let's talk about number 3. Together. So let's say I give you the linear regression equation. Y hat is equal to, your calculators say like AX plus B. This linear regression model determines the income a family needs to earn to stay at the median based upon the family size in a certain city. There's government data on the size of your family. What puts you in like upper middle class, lower middle class, that sort of thing based upon your family size. All right, so what's the explanatory / predictor variable? The predictor variable is your family size. Family size predicts how much money you are going to need. All right, and is there a positive or negative association? Positive, just look at the slope. All right, family size, the predictor variable. Positive association because of positive slope. So on B, it says explain the slope and the y-intercept in context of this problem. So the slope is 18.953, and that means for every 1% increase in family size, 18.935 thousand K there of extra income is needed to stay at the same income level. For this, that would be like the median level for a family of said size. All right. The y-intercept is 55.701. As I told you before, the y-intercept alone in a linear regression model, if you're just going to state the y-intercept of what it means, it's not incredibly useful. But when you start finding residuals and stuff, then it becomes useful. So that means that if you have a family size of 0, you need 55.701 thousand to be at the median. And on its own, that just doesn't make much sense. All right, but when I start, family size of 1, 2, then it's useful. So find the income needed to be at the median level for a family of size blank. So look at that. I didn't even have a calculator. I was making up these notes. So plug 4 in for X, 18.935 times 4 plus 55.701. I'm typing that in, and that is 131,441. So, like some places, if you look at northern Illinois, like Aurora, Naperville, like the median family income up there is very, very high. It's also a lot more expensive to live up there than it is in the southern part or central parts of the states. Okay, so 18.935 times 5 plus 55,701, a family of size 5. That's $150,376. All right, that's a point because this is in terms of thousands of dollars. All right, so calculate the residual for a family of 3 with an income of, that's their income. We have a family of 3 there. Okay, remember residual is y minus y hat. So their actual y is 115 2, 3, 4,000. So I need to figure out what they should be making to stay at that level. 18.935 times 3 plus 55.701. 112,506. Okay. So again, it's y minus y hat. The residual is y minus y hat. So we're going to do y minus y hats. So they are overperforming. They are making a little bit more money than they need to stay at a certain income level in a town. 2.728. All right. Calculate the residual for a family of 6 with an income of $134,507. Y hat equals. And when I looked this up a few years ago, it was about $18,000 a year. So for every increase, and that's mostly children, for every additional child, it came out, and sometimes it lowered, you know, between like $15,000 and $18,000 of initial income was needed. Hence the slope 18.935. So Y hat's 169.311. A lot of that is especially at the beginning. Daycare, one thing there that can be quite costly. So that is what's needed to stay at a certain median income level in a certain town, given a certain family size. So 134.507 minus 169.311, that is a negative. So a negative in this regard means underperforming by almost $35,000. All right, so that is page 3. Now, page 4 requires of us to get a calculator out, start typing some numbers. So I would pause this video now. This goes in list 1, this goes in list 2. Now, 95% of you are using this calculator. If you're using the TI-84, you hit stat, edit. You're going to edit list 1 and 2. I think in list 1, you should type your X values. Well, I mean, it is in list 1. And in list 2, you should type your Y values. Okay, so if you're using this calculator, you hit data, and then you type all the X values in list 1. You type all the Y values in list 2. So take your time doing that. There are 26 of each. So when you get down to 26, hopefully you're done. Nothing in the 27th. So take your time, pause the video right now, make sure all that's in there. Give you 5 seconds. All right, I'm not gonna wait because I wanna be done. This is the 4th video made today. So when you're done with that, you hit second mode, and even if you have the other calculator, hit second mode. If you're using the TI-84, then you hit stat, linear regression, over to calculate, stat, calculate, linear regression. Follow that. Again, depending on your calculator, you're going to have to know how to use it. I think maybe there's 2 of you that you're using the TI-84, actually. So then you're going to hit, if you're using this calculator, you're going to hit seconds, data, so stat. This is 2 variable statistics. You have 2 variables, you have an X and a Y. I'm going to hit enter. My X data is in list 1, yes. My Y data is in list 2. I'm going to go over to calculate. Okay, if you do if you're using the TI-84, you just hit linear regression, X data list 1, Y data list 2. Make sure you go to mode. You want stat diagnostic on, so it gives you the correlation coefficient, which is R. If you're using this calculator, you got to scroll down a little bit. All right, there. Now we'd expect a negative slope. The more classes you miss, probably the lower your grade's going to be. So Y equals AX plus B. All right, so I'm going to calculate the linear regression equation. I'm going to write it over here real quick. So Y hats is negative 1.64 plus 95.01. Oh, don't forget to attach the X. So it's a negative 1.64x plus 95.01. Is there a negative or a positive association? It's negative. Look at the slope. Slope's negative, that's a negative association. So if the slope's negative, my correlation coefficient also has to be negative. Negative 0.789. Its strength, so we'll write these down to, when I see you in class, but anything above 0.7 or below negative 0.7 is we're gonna call strong. We're not gonna say very strong, but this is strong negative correlation. More classes you miss, the worse your semester grade is gonna be. Obviously, there's gonna be some outliers. So find the predicted grade for a student who misses 2 classes. So y hat is negative 1.64 times 2 plus 9501. I'm getting a little gutsy here and not use a calculator. Okay. So y hat would be a 91.73. That's the predicted grade. Calculate the residual for a student with 5 absences who earns a what? Who earns a blank. We'll say who earns a 90.5. All right, so that's what they actually earned. That's their y, 90.5. Let's find out what they should have earned. All right, negative 1.64 times 5 should be a negative 8.20, which I will just check, but that should definitely be it. Great. And then you're going to have 95 basically minus that, so that's an 86.81, right? Uh-huh. Awesome. So they should have gotten an 86.81. They actually got a 90.5, so they overperformed. Y minus y hat is going to be, I believe that, overperformed by 3.69 points. Okay, that's it. That's where we type that in a calculator and get those answers. So that is fantastic. Now we are going to talk about page 5. I think this is something I can talk about in a video. State the 3 strongest and the 3 weakest correlation coefficients. So anything with an absolute value closest to 1 is strong. Remember, you can be strong positive correlation, but you can also have strong negative correlation. So the 3 strongest are the ones that are going to be closest to either 1 or negative 1. And the 3 weakest are going to be the ones that are closest to 0. 0 means no correlation. It's just a cloud of points. So the 3 strongest, that's the strongest one. Negative 0.77 is the second strongest one, and 0.68 is the third strongest. 0.7 is barely bigger than 0. 0.12, same thing, and negative 0.23. Those are the 3 weakest. In B, the 3 strongest, negative 0.79, negative 0.73, negative 0.72. Again, if I made an error, just correct it. The 3 weakest, 0.11, 0.17, negative 0.34. On C, the 3 strongest, 0.94, negative 0.89. Then it really just drops, doesn't it? Negative 0.60. 3 weakest, negative 2.2, negative 2.7, negative 3.9. 3 strongest in this one, negative 9.6, 0.94, negative 8.4. 3 weakest, negative 0.7, 0.29, 0.33. Okay, that should be pretty easy. I sometimes ask you those questions. All right, so that's page 5, and we'll talk about page 6. When I see you again, we did page 8 in class. We'll get that if you need to. And the last one I'm going to do with you, I believe, is page 9. Let's just get these down, and that is it. So if the correlation between 2 variables is close to 0, you can conclude that the scatter plot is definitely not going to be a straight line. Now, it could be a cloud of points, but it could also be something like this. So that's quadratic, and sometimes income's like that. Like if you peak earning age and then on average earning less. So I think we have an example somewhere, notes of that. So there's no straight line pattern, but there might be a strong pattern of another form like that. So the correct answer is C. The points on a scatter plot lie very close to a line who has that equation. That is a negative. I know this isn't written great. Negative association means it's negative correlation. You can't have correlation coefficients are always between negative 1 and 1, so that can never happen. And it's negative, so it's going to be very close to negative 1. If women always married men who are 2 years older than themselves, then the correlation between the ages of husband and wife would be 1. Be exactly 1. Because if a woman's age is 27, you know the husband's 29. If the woman's age is 22, the husband's 24. You know you can predict perfectly. For a biology project, you measure the weight in grams and tail length in millimeters or minus. The correlation is 0.7. If you had measured it in centimeters instead of millimeters, what would be the correlation? Still be the same correlation. All right. Still would be the same correlation. Okay. Folks, that's your notes video. This is Yak Math Videos, and we are signing out. I will see you on Tuesday.